All right, Algebra 2, we are moving on to some of my favorite stuff. If we were in school, we would be having a lot of fun with this because there are a gazillion questions that I make up in a gazillion twists and turns. We'll do it again next year in Pre-Calc Honors, so we still have that opportunity to have that fun. We're on lesson 11.5, and we are talking about, I can't even find the name of this lesson, sums of arithmetic and geometric sequences. Our essential question is, can you find sums of arithmetic and geometric sequences in series? The new formula that we're going to use is this one right here. It is the sum of the numbers, S sub n, is equal to, I typically write this as n over 2 times a sub 1 plus a sub n. Now, this one's written totally different, so let me write down the way I write it. I usually write it as the sum of the numbers is equal to n, the number of terms divided by 2, times the first term and the last term. So let's talk about where this derives from. There's a great old mathematician, his name is Gaussian. We've talked about him probably before. Well, Gauss came up with this great way, and actually it's the only way I remember how to do this formula. I'm not one to know formulas, I'm one to understand formulas and apply them from there. I do have this on my SAT ACT cheat sheet. It's called the New and Improved SAT ACT cheat sheet, and it is in your stream on Google Classroom. So this guy Gauss came up with, well, what happens if I was to add 1 plus 2 plus 3, all the way to 100. And what Gauss came up with is he said, hey, if we take this, and if I add it backwards, 100, 99, 98, all the way to 1, we're going to find ourselves a little pattern here. And so this is what Gauss came up with. Notice when I add down, first term I get 101. The second term, I get 101. The third term, I get 101. And notice every time I add this down, I'm going to get 101. And that's why he used this formula right here. This is saying the number of terms. Well, in this case, I have 100 terms divided by 2. And we're dividing by 2 because remember good old Gauss made 2 rows. So we're going to take that and divide by 2, because what we did is we took the first plus the last. So if I was to work out this problem, I would have 50 times 101, which is equal to 50/50. This is a very, 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 very common thing that you see on college placement tests. We haven't started working on those yet. We'll work on those in pre-calc. This is a very common thing that you will see on an SAT and an ACT and all those standardized tests that you guys get to take. So please take note either how I remember it, how Gaussian taught the world of mathematics, or go ahead and just memorize the formula. All right, so let's take a look at the first problem that we have. It says find the sum of the first 20 terms. Well, they don't tell us the first and the last, do they? So the first thing we do have is a problem. Our problem is we don't have the first and the last. So I have to find out the 20th term. Well, I know what's happening here is I am subtracting 3 with each. So I can use the arithmetic sequence that we were given earlier. So I am finding the 20th term. I'm going to take the first term, and then I'm going to take n minus 1 times the common difference, which is a -3. Once I figure this out, I can just go ahead and distribute. So I have 8 plus, hey, remember we need that 20th term. So I'm going to put 20 in right here for n. So that would give me 19 times -3, which ends up being 8 plus 19 times -3 is -57, and I end up getting a -49. So I know the last term here is negative 49. So I'm finding, remember they said that there are 20 terms. So now I'm going to go ahead and use that over here. So I know there are 20 terms. So I'm going to use that formula, S sub n is equal to n over 2 times the first, times the first plus the last. There were 20 terms. The first term was 8. The last term was a negative 49. When I go ahead and multiply that, and I multiply that all out, oops, that was just 41. I get negative 410, I was working ahead. So the answer for this whole question is negative 410. But remember we had to apply what we learned last week, the arithmetic sequence. We had to apply the arithmetic sequence first to find that 20th term, and then we plugged it all back in to find the sum of the numbers. The rest of our notes is just going over some of those that you could just throw in your calculator. So I'm not going to bother with those. I'm going to go over some other questions that are really popular. So example 2, I'm going to talk about the sum of the numbers from 1 to 50. So again, we have the number of terms divided by 2, the first term plus the last term. There are 50 terms, and we're going to multiply that or divide that by 2. We're going to take the first plus the last. So it looks like we get 25 times 51. So the answer to this question is 1,275. All right, the last one I'm going to look at is going to be kind of strange. So you're going to be able to figure it out, and we will do a ton of these in pre-calculus. What if they ask us, all right, so this one, I'm on example 3. They're going to tell us to find the sum of the numbers. But this time they're saying, hey, we're going to go up by 2. And this is going all the way to 99. So we have a little bit of a different problem. We can use that same formula. But we have a problem because a lot of times we forget what the sum of the numbers are. So the first, or how many terms are, the first thing we have is we have 1 to 99, which would be 99 terms, but it's going up by every other number. So we have to do 99 divided by 2 again. So can't I just divide that by 4? Or if you wanted to be exact, you could write that as 99 divided by 2, all of that divided by 2. You'll see what I'm doing here in a second. When I take the first plus the last, that conveniently gives me 99 divided by 2, which is 100. So this becomes 50. Does that make sense? So now what we have is 99 divided by 2 times 50. And again, we can cancel out to get 99 times 25. Well, on my good old calculator, if I take 99 times 25, I get 2,475. All right, the only other thing that I really want you to be cautious of is when doing this is a lot of the times they're going to ask you, you're going to laugh at this because you're going to be like, wait, I didn't get that. They're going to ask you the sum of the numbers from 30 to 40. Now, it's really easy. You could just take in your calculator 30 plus 31 plus 32 plus 33. And a lot of you might take the time to do that. But if you are going to be creative and use the formula that we've been working with, which would be wonderful, the only thing that you have to remember is that from 30 to 40, there are not 10 terms. And I know you're thinking, wait, 40 minus 30 is 10. You are correct. But remember, from 0 to 10, there are 11 terms because we have 1, 2, 3, all the way to 10, plus that 0, which gives us 11 terms. So remember from 30 to 40, because of that 0, there are 11 terms. And if I take the first and the last, I have 70. And I can cancel here, and I get 11 times 35. And 35 times 11 is 385. Hey, while we're here, let's talk about that fun little trick. 11 times 35, if I multiply anything through by 11, we can split the 3 and the 5, add it up, throw it in the middle, and that was the answer in the calculator. Just for good times, memorable sake. Great job on lesson 11.5. I gave you a lot of extensions there to work on, so study hard.